pinion gear here, the pinion shaft, it's supposed to have 8 to 10 inch-pounds of rolling drag. Instead, it has about 20 thousandths of end play. So that's not good. So what I think we're going to do is yank the old transmission out, and we'll stick the whole parts, transmission, steering clutch, differential, the whole shebang into this machine. We've got a complete steering clutch ready to go back in the transmission. I ended up pulling the input shaft out of the transmission. It's supposed to have 3 to 5 thousandths of end play. It had about 35 thousandths end play. So I want to replace the 2 bearings that support that. They're just deep groove ball bearings. And then I need a speedy sleeve for this bowl gear. That's on the right side. Final drive.
It's like I've already gone through a 6-pack and I need more.
Howdy folks, welcome back to part 4. Yeah, 4 on the Oliver OC46 Crawler. I think I got all the parts. Let's start putting it together. Alright guys, between the main clutch and the main transmission there's a little auxiliary gearbox. On this machine it's a reverser, so it just reverses the direction of the input shaft in a 1-to-1 ratio. There was also an optional low-speed gearbox that would give you, I don't know, some lower ratio. Anyway, we're going to stick with the reverse gearbox, but I pulled it out because I wanted to replace the seal here on the input shaft. I think it's been leaking pretty badly. So I installed a new seal. The new seal is a little bit thinner than the old seal, so I had to drive it in a little bit, maybe a little bit further than what you would think. And then here's the input shaft. I put a little bit of grease on the pilot bearing and on the seal surface. So the big thing with this is don't push the clutch pedal while you have this shaft removed, because you're going to lose the alignment on your clutch disc. So this is the reversing gearbox, and I'm using the Loctite 515 flange sealant on this surface instead of a gasket. It did have a paper gasket. It came off mostly intact, but I don't want to try to recreate it. It's just so tedious. This 515 Loctite stuff works really good for nice flat machine surfaces, anything that's flat within about 10 thousandths, about 0.25 millimeters. And it also works well, in an application like this where you're close to bearings and gears and stuff, because this stuff stays kind of pliable and soft until you take away the oxygen. It's an anaerobic sealant, kind of like other types of Loctite. So yeah, the Permatex number 2 or number 3, the aviation stuff, kind of works the same way. It's sort of oil soluble until it sets up, and it won't really set up until you put it in a flange. We're going to use the 515. We'll see how it goes. That's just 3 bolts to hold that in there. Oh, I wish I could blow these parts off, but the air compressor is temporarily out of commission. Well, there is our output shaft. So that's the neutral position, that's the forward position, and then all the way back is the reverse position. Let's see if I push the clutch, you can see that. So you see the output is exactly reverse of the input. And somebody commented in the, I don't know, the first video maybe, that you could put the reverse box in reverse and the main transmission in reverse and then get an extra low forward speed. That's not the case with this gearbox. It's 1-to-1 ratio. I think I found the problem with my air compressor. This is the unloader, the hydraulic part of the unloader. So this uses oil pressure from the compressor to push this piston out, and that actually cuts off the air supply to the unloader valve up on the top of the head, and uses oil pressure between this seal and this cup seal, this O-ring in the cup seal, and this cup seal has seen better days. So I finally found an O-ring kit. They make an actual rebuild kit for this unloader, but I'm having a terrible time getting parts for this thing. I called 4 different places. No one would call me back. I finally called a local air compressor repair service. They thought they might have had something, but he didn't get back to me. I called him back again, and we finally came up with a seal kit. Now, it doesn't have the springs and the little, whatever you want to call it, pop it inside here, but I think it's got enough to get us going again. So there's a quad ring here that's going to replace this O-ring, and then a new cup seal. And I tried even like the local hydraulic shop that rebuilds hydraulic cylinders. They couldn't get this cup seal. It was some kind of special oddball size. So anyway, let's put it together, see if it works. Oh yeah, that's way better. The old one was just hot dog in a hallway. The old seal. So hopefully this fixes our problem. Okay, power's turned back on. Good on oil. Let's see what happens. Well, that didn't fix it. It's better, but it's still not right. Problem is it's losing oil pressure. So what happens is this gauge is a little bit off, but it goes up to about 25, which is actually 15. And then every maybe 20-30 seconds it drops back down to this 10, which is actually 0. So the pressure is dropping completely off every 20-30 seconds. And when that happens, the unloader opens up, and it basically stops pumping air. I tried to adjust the oil pressure regulator here. It doesn't seem to make any difference where I put that. It still periodically drops back down to 0 on the oil pressure. I thought replacing that cup seal would fix the problem because the oil was leaking past the cup seal, but that wasn't it. So I guess there's a couple more options. You may have a bad pressure relief valve if there is one. Could have an actual problem with the oil pump itself, or we may have a problem in the bottom end and it's losing oil pressure. So I don't know. This compressor is old, but I don't think it has a whole lot of hours on it. It was a backup compressor, came out of a state maintenance garage, like for the DOT, and this was their backup compressor. Now when I got it, it had been sitting for a long time, and I had to rebuild these poppet valves. There's some fine surfaces that have to be lapped in order for those to seal. And if the poppet valves don't work, it won't build air pressure, and then it'll also leak back out of the tank because there is no check valve on these Quincy compressors. It's all done with these poppet valves. Anyway, these are good compressors, but I don't know how far I want to go with it. So maybe we pull the oil pan off, the oil cover off the side here, see what we can see. I don't know, go from there, I guess. Well, I fixed it. I was going to say I fixed it by changing the oil, but that's not entirely true. This compressor doesn't have a spin-on oil filter. Some of these compressors, instead of having this plate here, they have a filter base, and you just spin on a disposable filter. It'd be nice if this had one, but it doesn't. Instead, right here is a big plug. That's actually the end of the pickup tube. The pickup tube fits, it sticks way back here in the crankcase and sucks oil up into the oil pump, which is right here behind this cover. And the pickup tube actually fits inside of a mesh screen. The screen is kind of a tube. It's about yay big around and about as long as my hand. And that thing was clear full of goo. And I don't know 100% why. I change the oil on this compressor pretty regularly. I try to do it once a year, which, for the number of hours that it runs, that's kind of overkill. But yeah, I have never serviced that screen before. I did, when I took this cover off to reseal it, I did clean the outside of the screen, but I never cleaned the inside of it. So anyway, it's fixed. It'll actually bury the needle here on the oil pressure gauge. Now I had to back the regulator way out to get the pressure back down to where it should be. So yeah, simplest things first. I should have tried that, before I went after that unloader. But I've only got $13 in that O-ring kit, and we needed them for the pickup tube. I had to replace those O-rings, and I took that apart anyway. So no loss, and I did change the oil, so it should be good to go. Yeah, pretty stupid. Anyway, let's move on. All right, we'll install the output shaft here. And then I had to make a shim. It's this guy right here, 15 thousandths thick. So the service book says just to shim that until the bearing can just move back and forth. So it had about, 19, 20 thousandths of clearance. I put a 15 thousandth shim in there. I think that'll be just fine. They're the same bearings. The bearings were fine. It didn't have a shim in it before, so who knows? Yeah, I don't know if I mentioned it, but I used the Loctite 515 sealant on that bearing cap there, and we're going to install the cover. There's a ball and a spring. That's the detent for the shifter. Got those installed. And there's a sheet metal cover. I'm using the Permatex Ultra Gray. This is not a good application for the 515 flange sealant, because this top cover is pretty springy. The 515 works well when you have two machined surfaces, but when you have a piece of sheet metal like this, silicone is the way to go. I think silicone's even better. RTV would be even better than a gasket in this application. But that's my opinion. And yes, I am reusing 2 of the old bolts and installing 3 new bolts. Alright, we need oil. I'll show you what the book says to use. It's basically the same for the final drives, transmission, any of the gearboxes. It says to use SAE 50 for your normal operating temperature. In colder temperatures you can use SAE 30 or even 10W30. And at the bottom there's a note here that says if SAE 50 oil is not available, use SAE 90 gear oil. So we're going to use SAE 90 gear oil. This is some stuff I have. It comes from Napa, and it has a GL1 rating, which means that it should be safe for yellow metals, bronze, brass, whatever. So any gearbox that has thrust bearings or bushings or whatever, this oil should be safe for that. Lots of tribalism involved with oils, especially when you have older machines and you're trying to apply new oil technology to them. Can get very confusing. The general consensus seems to be that the newer GL4 rated 8090 gear lubes are not safe for yellow metals. I have never personally seen bronze bushings or synchronizers or whatever that were damaged by the gear oil. I've never seen that in person, but that's what everybody says can happen. So yeah, this stuff here should be safe for that application. Now, if you want to get 50 weight oil, that is what's used in Eaton Fuller truck transmissions. So any good truck repair shop should have 50 weight oil in stock. Anyway, I have this 90 weight gear oil. I use this stuff in various machine tool applications. This is actually what I use in my brake lathe. Yeah, that's what we're going to use. And the reverse box is done. I think these two bolts have to come back out to install the shifter, but yeah, otherwise it's ready to go. All right, let's get back to the transmission. Got 2 new bearings. And they are shielded. And 1 new seal. Like so. Now, we only need the shield on one side, so we're going to have to pop one of them out. There we go. There we go. So they keep the shield on the outside just to help keep the oil in the bearings. They're not really the seals. It has an actual seal. It just keeps the oil, you know, where we want it. Inside the transmission. I'm not going to take the grease out either. That won't hurt a thing. It'll dissolve in the oil and everything will be happy. I press the bearing onto the shaft up against this snap ring, and then the second bearing goes right there, but I have to move that gear cluster to get it in. Alright, the input shaft is stuffed back in the transmission. That is this shaft way down here. So I'll show you guys the different gear ranges. So that right there should be first gear, lowest gear. And then, let's see, not that one. That right there should be second gear. And then third gear. And then that one in neutral, and then this one over. That's reverse. And then when it locks that little collar, that is high gear. The high gear is actually a helical gear, which Oliver was that was kind of Oliver's deal, was to use helical gears in their transmissions. They're supposed to be quieter, but in this one it's only in the high gear. Now we have to install this bearing plate on the end. That's it right there. Press the new seal in. The new seal is quite a bit thinner than the old seal, so I pushed it in kind of extra far. And I don't know if you can see that, but that shaft is kind of chewed up, so I want the seal to be inside, well inside that chewed up area. And I found the appropriate shims to give us 3 to 5 thousandths of end play. We're going to use 2 12 thousandths shims. I am going to use this Loctite 515 again between the shims and the transmission housing, and between the shims and the bearing plate. Now I have seen on a lot of machines, especially machine tools, where they just put the shims in dry. And a lot of times they'll have a gasket on top of a shim, or a gasket on top of a stack of shims, and then the shims right up against the casting. And yeah, no actual sealing there, but it seems to work. And there's various theories on, you know, what to do about that. Some guys like to use grease on the shims, so they'll just layer it with grease, especially dielectric grease works pretty well. Or you can use high tack, especially like the aerosol spray high tack works pretty good. Now we're going to use the 515 because this one isn't super critical. But yeah, it's kind of tricky because you're trying to seal so oil doesn't leak around these surfaces, but you don't want to affect the shim stack, the tolerance. So it kind of gets, it gets a little tricky. Alright, I'm happy with that. Now we're going to install the shifter. Okay, there's a little pin. Goes in here, like so. And the shifter keys into that little pin. Like so. Very good. A little more goo. And there's a retainer. And we're going to try to turn that so that the worn spot doesn't correspond to the notches in the shifter. Probably needs a new one. But what are you going to do? I think it'll be fine. Usually shifter parts aren't too hard to get because it's a common problem area for all tractors. They get water down inside of them, and then pretty soon you got problems. There it is. I've got 3 of these yokes for the little short drive shaft that connects that reversing box to the transmission. They all have various problems. See, this one's got some pitting there on that boss. This one has some too. But I think this is the worst one. See, it's had a little bit of a bush fix. Sometime in the past they welded a piece of steel over here to keep this cap from flying off. And it's broken loose again, so I don't want to put that back on. We're going to use these 2. The heck are these guys doing? I think they're busting out the reflectors in the middle of the road. Gotta love Illinois. We've got roads with potholes and bumps so big it'll literally knock your vehicle apart. And they're out here changing out the reflectors in the middle of the road. Alright, transmission is installed, drive shaft is installed, or coupling, or whatever you want to call it. Hooked up to the reverse box there. Looks good. Next step, we're going to clean out this differential housing and install the steering clutches. That unit is ready to go. Then we can transfer the linkages for the brakes, install the brake bands, and then we should be able to test out the steering clutches. Hey lady.
Hi.
How was your day?
It was eventful.
Hopefully it was better than my day.
My team lost both the over-under and the tug-of-war, so I failed 30 students today. Because they don't know how to compete.
Wrap up. Sounds like we got a lot of learning done.
I see you're busy.
Yeah, it's been a couple weeks, quite a couple weeks.
All right. Well,
I'm tired. Max, buddy, I can't talk. It's making it kinda hard to do a YouTube video. Steering clutches. They're in. I'm working on the setup for the bearings and the gears. The way the book tells you to do it, the service manual tells you to do it, is to take all the shims that you removed from under the bearing caps and put them all under the left side cap right here, and then add 20 thousandths of shims under the right side cap, and we should have some amount of movement this way between the bearings. That's our end play. And then we also should have a large amount of movement between the gears. That's our backlash. So what we're going to do here, got an indicator set up, we're going to measure the end play between the bearings, and whatever number we come up with, we're going to subtract that amount plus another 5 thousandths from the shims, and that will give us a 5 thousandths preload on the bearings. So it's actually squeezing the bearings together by 5 thousandths. Once we get that set, we're going to flip the indicator around and we're going to measure on the inside of the gear teeth, and we're going to measure the backlash. We need that to be, I think it's 6 to 8 thousandths, somewhere in there. And in order to set that, we're going to swap shims from the left side bearing cap to the right side bearing cap, and that will keep the end play the same, or the preload the same, but it's going to move the whole unit over. That looks better. So I think we have about 5 thousandths of end play right now, maybe 6 thousandths. Yeah, getting closer to 7, aren't we? Alright guys, I'm going to call that 6 thousandths of end play. I know it drives people crazy that I don't zero out the dial indicator, but I'm so used to working with them that it doesn't help me. So the backlash is massive, as you might expect, because all the shims are on one side. So it's like 55 thousandths. Alright, I removed 10 thousandths worth of shims, and then I moved 20 thousandths worth of shims from the left side to the right side. The backlash now is I'd say right around 40 thousandths. So 20 thousandths worth of shims only changed the backlash about 10 thousandths. So I think we've got quite a ways to go on that. I think we got it. So the spec is 6 to 10 thousandths. It's about 9 right now. Maybe 8. So I actually had to remove all the shims from the left side and put them all on the right side. But that's how it was before. This is the spare parts, the parts machine transmission, and when I got it, all the shims were on the right side bearing cap. So we're right back where it was, and we're done. The only other thing we could check is the contact pattern between the two gears, but we haven't changed the pinion depth, so I don't see any reason to do that. And it's a huge kind of a pain in the butt to change the pinion depth on this machine. It's actually done with a variable thickness snap ring. So you have to, way back inside there, you have to pull the snap ring out that holds the bearing, the bottom bearing for the pinion, replace it with a different thickness, and then go all the way back up to the front side of the transmission and tighten up the jam nut to reset the preload. So we don't want to get into that. It's going to be just fine like it is. So this is a classic example of where a precision locating surface is also a sealing surface, and there just really isn't any very good options for that. We cannot put any kind of a sealant or gasket on these shims because that's going to affect the bearing preload that we just spent all that time setting up. Everything has a little bit of thickness, especially with these shims. I think there's 8 or 10 shims. So if you added a sealant here that was 1/1000th of an inch thick between each of these shims, you just added 8 thousandths to the stack up, and that's no good. But we need to have something because there's oil inside this transmission, and if it leaks out around this bearing cap, it can leak between the frame and the transmission, or it can leak down into the differential. It doesn't really matter if it leaks into the final drive. If it leaks into the final drive, that's not the end of the world, but there is a leak path right here to the outside, and it's just kind of a crappy design. A lot of older stuff is built this way, and there's not a whole lot you can do about it. So what I'm going to use is just a little bit of Sil Glide. This is silicone based grease. So I just put a little film of it on each one of these shims, and this will squeeze out, and it will not have a thickness, so it will not affect the stack up, the tolerance stack up that we have here, but it'll fill any voids if we have them, you know, defects in the casting or whatever. And because it's silicone based, it's pretty resilient. You know, silicone based greases don't wash off easily. So this one's protected by the final drive housing, but if it was an exterior application, that would be, you know, that would be a good choice. And then on the bolts, we're going to use a little bit of this 515 flange sealant because the holes are tapped all the way through. And we'll use our cotter pin pullers, split pin pullers to clip the wire here. There we go. Steering clutches installed. If we had some brakes, we could test them out. Pretty windy out there, isn't it, pup? Yeah. I've got the brake bands installed and adjusted. I've used the best two that we had out of 4. This one on the left is quite a bit better than the one on the right. It's got a lot more material. So you see I shortened the link on the right side. They're supposed to be 2 13/16, but that's way too long, I think. So they both must be worn a little bit. Anyway, I'm going to show you how this works. I'm just going to use the starter motor to crank it over, and you'll see the brakes in action. So here we go. Left side. Right side. Cool. So it works. That's as much as I want to do without putting some oil in it, but the proof of concept is there. All right, folks, I'm back to work on this Oliver Crawler project. As you know, some time has passed. Fortunately, that's how it goes. The good news is I think the harvest is about over. These guys get another week of decent weather, which, you know, is not a given. They should have all the crops out, and then it's down to maintenance stuff, you know, mowing, some tillage, spreading fertilizer, that kind of stuff. And they have, I would say, at least another month before there's frost in the ground, so I think they're going to be just fine. And that means after the end of next week, things should cool off around here and kind of return to the normal pace. If you've never lived in an agricultural area during a seasonal harvest, it's just, I can't even describe it to you. People are just, I don't know, they're crazy. And, you know, you can kind of understand why. A lot of guys have hired seasonal help, and they got a lot of money on the line. Equipment breaks down, they can't work, they can't, you know, harvest their crop and get that payday, and it really messes them up. So we try to do the best we can to keep everybody running, but it gets pretty wild around here. Anyway, I'm tired of it. I'm sure they're tired of it. So yeah, another one in the books. Anyway, on this project, we have the steering clutches installed, tested, it works. We went ahead and installed some sheet metal. That's the seat tray or whatever. We're going to get the battery box and fuel tank installed, I think. My next move is to get the final drives assembled and installed on the machine. And I'm running into some snags, as you might imagine. So this is the right side final drive that was on the machine originally, and it's no good. Well, other than being slimy and greasy, there's nothing wrong inside here. The stub shaft is good. This is all cool. The problem is back here. You can see this boss, that's part of the final drive housing casting, and it's broken here. It's been broken there for a long time. And then that stub shaft, when it's pressed in, they welded it to the boss. Not sure what they used, nickel weld or something. Anyway, when I removed the nut from the end, this one was kind of stuck, and it ended up just breaking a big piece of that casting clear out, and the welds separated. And anyway, we cannot reuse this. We would have to somehow attach this boss back to the casting, and there's really no good way to do that. This is the opposite side final drive housing. It's okay on the back side, but the problem with this one is inside. Somebody's peened this bearing journal right here. So I don't know if they had, the bearing was, the journal was worn and they were trying to peen that up so that the race wouldn't spin. That's the only issue with this one. We may be able to live with that. And I also have the final drive housings from the parts machine. I don't know which one's left and which one's right. This one, the welds are broken. Otherwise it seems to be in decent shape. And this one seems to be fine. The welds are good. The only problem with this one is it had water in it, and it's pretty rusty on the inside. Well, folks, it took me the better part of an entire day, but I finally got one final drive unit assembled. It is no small task. All right, here we go. This is the bowl gear out of the final drive, and it's got pretty substantial wear here on the sealing surface. So I was able to score a speedy sleeve, 99575, and it's an NOS part off of eBay. Cost about half what a new one would cost. Still pretty pricey. Anyway, we're going to use a little bit of this 515 Loctite and drive it on there. Now what's interesting, I don't know if you guys can see it, but this sealing surface is actually already a sleeve. So that's a removable cup basically that fits over top of those studs. And if I was smart, I should have called whatever company supports these machines and seen if that part was available instead of trying to track down a speedy sleeve. It probably would have been cheaper. But too late now, already got it. Alright, I'm going to have to clearance this installation tool. Perfect. I guess we might as well finish the assembly of this bowl gear. It's kind of a pain in the butt. So there's a bearing in the front. Install that first. Now we need to install the actual bearing first. Alright, next there's a sleeve that has a shoulder inside, and the seal gets pressed up against the shoulder from the inside, which is kind of a pain in the butt. So what I found worked pretty good. I had this old bearing cage off a tapered roller bearing, and I split it and slipped it right down inside of that seal. Then I could use that as a press tool to press the seal in place. Otherwise you're pushing on the sealing surface. There just isn't really a very good way to do it. This is a pretty poor design. Anyway, the sleeve gets installed like so on top of the bearing. And again, I use a little bit more of that 515 flange sealant on that. So that's the front side all ready to go. And we'll install the big bearing race on the back side. Alright, moving on to the final drive housing. Install the bearing race. Oh, that's not good. Well, what are we gonna do about that? All right, guys, there's a couple things we could do with this bearing journal. And we could take a center punch, come in here and dimple the surface, try to knurl it a little bit, make the bearing race fit tighter. We could glue it in with some Loctite. They even make special bearing race retaining Loctite. It's supposed to be good for up to 10 thousandths. But honestly, that stuff never works, not in the real world. I used to see it all the time when I worked on machine tools. You know, millwright repairs or maintenance man fixes, whatever you want to call it. You know, they're Band-Aids. That's not the right way to fix it. The right way to fix it would be to put this in a milling machine, bore this out, press in a sleeve, bore that out to the right diameter, and then press the bearing in. And on the stub shaft, you see it's already been millwrighted or maintenance manned. So yeah, what we're going to do instead is toss that final drive housing in the pile. And I went ahead and prepped this one. This is the other final drive housing from the parts machine. Oh boy. It was the one that had the cracked welds on the stub shaft back here. So I just touched up those welds and cleaned up the inside. We're going to go ahead and build up this final drive housing instead. Should be just fine. All right, success. I tipped her up on her back, and that made all the difference. So, oh, come on, guy. Now we have to set the bearing preload, which is a little bit tricky. Show you how it's done. Urgh. Use my axle nut socket here to take this nut off. So underneath of this spacer is a stack of shims. And I just took a big fat guess and put some in. And there's no preload right now. Can't feel anything. So I'm going to take two of these little skinny guys out. And we're going to try it again. Okay. I still don't really feel any rolling drag, so I'm going to piddle around with this for a minute. I'll bring you guys back. Alright, I think we're pretty close to being dialed in. Now the reason these vice grips are here is to give us a place to hook up our fish scale, and we're actually going to check the rolling drag with a scale. It's supposed to be 6 to 8 pounds of rolling drag. So here we go. Yeah, it's a little bit tight. So you can't go by the initial because, you know, static friction is higher than rolling friction. So you want to kind of check it as it's rolling. It's kind of tricky to do. Alright, so it seems to me like it's closer to 10 than 8, so let's put one shim back in. Oh, here we go. Come on. Alright, I'm calling that good. It's right about 8. So let's quit while we're ahead. And we'll go ahead and torque this nut to factory spec. Click. Now before you go crazy down in the comment box, I've read the service manual and I haven't really found any published torque specs for any fasteners outside of the engine. So it's up to us to figure that out. Anyway, that part's done. I'm going to dimple this nut right here into the keyway. That'll keep that from coming loose, theoretically, and then we can put the cover on. Well, here we go. This seal is really tricky. Now the book says to install the seal with the lip facing out, but I just can't make myself do that. So we're going to try it with the lip facing in. It's a double lip seal, where the old one I think was a single lip seal. So that on the double lip seal, this outer lip will keep the junk out. So that isn't really an issue. Now there's 3 bolts that they call dowel bolts. So they just have a unthreaded shoulder, and they go in 3 locations. And there should be one here, and then one here. So when you tighten these up, you're going to want to do those 3 dowel bolts first. That should kind of align the cover, and then crank the other ones down. Alright, everything's snugged up. We're going to let the RTV sit for about an hour. Then we'll come back and torque those bolts down. Then we can install the pinion shaft and set the bearing preload on that. Alright guys, I went ahead and stuffed the pinion shaft in, and I just roughed in the shims. So the way that the service manual tells you to set this thing up is you're supposed to back off the big nut here on the bowl gear so that there's no preload on those bearings. And then you're supposed to wrap string around the pinion shaft and then pull on it with the scale, and you're supposed to have 2 to 4 pounds of resistance. I didn't find that to work really at all on the other final drive that I set up. So what I did, I don't know if it's right or it's wrong, I just installed shims until the shaft had just a little bit of play. You can hear it right there. And then what we're going to do, underneath of this cap are the shims. We're just going to take out shims starting with the thinnest one until the free play in the shaft goes away. And that'll give us a little bit of a preload. We won't be able to quantify it, but I feel like it's going to be close enough. So we'll just pull out one of these. One of the thin ones. I don't know where we're going to find it. That one looks pretty good. So we'll take that one out. Stick these back on. And we'll reassemble it. So it's still got a little bit of play. We need to take a little bit more out. I think that's it. Let's put all the bolts in it and see how it feels. Get my battery's on its last leg. Actually, this whole impact's on its last leg. Had the thing since Christ was a cowboy. Okay, I'm happy with that. Well, I think that's it. I installed the track frame bracket on the inside. New grease zerk. I removed all the drain plugs and check plugs. We're going to go through all those and try to find a decent set of 8. Well, here we go. The housing's rigged up on the gantry crane. Got RTV on the flange. The pinion shaft has been removed. The studs in the transmission have been installed. That flange is clean. And then I used my needle scaler to clean up this saddle in the frame that the final drive housing is going to sit sit down into. So we are ready to install. All right, folks, I really wanted to finish this project and just make one long, drawn-out video where we did all the reassembly, got the thing running, driving, did a shakedown, and kind of put this part of the project to bed. But it's not going to work out that way. There's too much more work to do. So I think what we're going to do is split the video here, and when we pick up in the next video, we'll finish everything. We'll get the sprockets installed, the rear cover, the tracks. We've got to do some work on the track frames. We've got some special grease for the rollers. There are new adjusting bolts for the tension adjusters here. We'll install those, and then we'll cross our fingers, hope that it works out, and we'll do that shakedown run. But it's just not going to happen in this video. I don't want to draw it out too much longer. I don't even remember where we were in the last video that I put out. I think that the transmission and the reverse box and everything was all still disassembled from the machine, and all I had done was put the clutch packs together. So we have done quite a bit of work since then, but we're not quite done. So sorry about that. I thought I was going to get it all put together for this video, but yeah. I mean, it's always more work than what you expect, but this one has turned out to be more work than even I expected. So yeah, that's how it goes. Anyway, thanks guys for watching, and I will have the final installment of this part of the machine coming up quickly. I don't think we're waiting on any parts. We're just waiting on me to get the work done. And then once we get it running and driving and get that part of it kind of settled, there is a loader attachment for this machine, and we're going to try to get that installed and working. The hydraulic pump's up there in that red box. We're going to install that, probably do some testing with it. And then I think there's a problem with the valve body for the loader, so we'll get into all that. Yeah, anyway, thanks for watching, guys, and I'll see you next time.